So today we are going to discuss acceleration due to gravity. Due to what? Gravity. Do you understand, everybody? So now, again in class 9th itself, third chapter, gravity in physics, we'll study again this freely falling object. So by the time also we'll study, but now itself we have to study. Even chapter 1 we are having importance. So as we know in last class, we derived 3 equations of motion or 4 equations. Can anyone tell me what is the acceleration first of all? For suppose if the car is moving, so when we can say what is the acceleration of the car formula? So acceleration A is equals to what? Final velocity minus initial velocity divided by time period. So this is what we used to call as acceleration. So now, if the body is having uniform acceleration, then we can say, Hari, tell me, uniform acceleration, then we have to represent the motion of a body, we're having 4 equations of motion. What is that 4 equations of motion? V is equals to U plus AT. Second one, S is equals to UT of AT square. You should speak, yeah. If you are silent, please don't attend my class. You leave it, no problem. Worthy and everybody, I'm saying. If you are silent, if you are not responding to me, get out from the class. No problem. I don't want anyone. So those are not interactive. What is the use of teaching? Next, 2AS is equals to V square minus V square.
V square minus V square. Sn is equal to
Sn is equals to
U plus
1 by 2 A
2n minus 1. Sir,
these are the 4 equations. Yes. Now,
sir, why we can't pronounce like off, sir?
which one?
And that 1 by 2, we can pronounce as off, no, sir.
Half into A into 2n minus 1. Okay. Now, if you notice,
Okay, sir.
yes, please observe very carefully. Now, if you notice it, now when we are representing these 4 equations, when the body is moving on the surface of the ground like this, yes or no? When the body is moving, uniform acceleration and also what? It is moving in a straight line. Is it yes or no? Yes, please respond. So uniform acceleration, the body is moving in a straight line, then we can say these are the 4 equations. Now, if the same body is moving away from the ground vertically or towards the ground vertically, this away from the ground, do you understanding? Thrown upwards, away from the ground, and it is what? Thrown upwards. Understand, everybody? So now, in this also body is moving. Yes or no? Now it is falling, freely falling. Understanding? So freely falling. So in this also body is moving in a straight line with a uniform acceleration. So if the body is thrown upwards or falling towards the earth, then some force is acting from the earth. So the force exerted by the earth only, what we used to call, guys? The force exerted by the earth is what we used to call. That is what we used to call as gravity. Do you understanding? So who is causing to acceleration of body when it is thrown upwards or when it is falling freely? That is what? Because of gravity. So that is what we are going to study in our today's class. That is only what we used to call acceleration due to what? Acceleration due to gravity. Clear, everybody? So now, if you notice it, when the body is displacing like this, you observe very carefully. When the body is displacing like this, we used to call it as, for example, distance covered by a body. What will represent? Distance covered by a body will represent what? Yes. Yes or no? Now, same body will be thrown like this. Then, what we used to call, guys? Yes will become what? Yes will become what?
Yes. Small s, sir.
Yes will become h. Height, ready. What are you talking, ready? Huh? If the same body is moving on the surface of the earth, we can say it is covered distance. If the same body is thrown upwards or it is falling freely, we can say it is traveling in a particular height. Yes or no?
Yes, sir.
Now, same thing you can say. When the body is traveling like this, when it is called as acceleration. What we used to call? What we used to call? Acceleration. Now, the same body is falling due to the gravity of earth. If the same body is falling due to the gravity of earth or thrown due to the gravity of earth, so acceleration due to what? Acceleration due to gravity. So that is why that is represented with what? Acceleration represented with what, guys? Gravity. Do you understanding?
G.
So when the body is thrown upward or falling downward, then distance will become what? Distance will become height, and acceleration will become what, guys? Acceleration will become, yes, please. Acceleration
Gravity.
will become what? G. Acceleration due to
Gravity.
that is what you have to remember. Now, observe very carefully, all of you. When the object is thrown vertically upwards, it will move what? It will move up to a certain distance, and then finally it will back to the ground. Is it yes or no, guys? Yes or no? For example, now here Harish is standing.
Yes, sir.
Now he has been thrown as some stone. So is it the stone is continuously traveling? Is it thrown is continuously traveling?
No, sir.
No. It is thrown. It is once the stone is thrown by the Harish, it will travel certain distance. After traveling certain distance, then what will happen, guys? It will back to the surface of the ground. Understanding? It will reverse to the surface of the ground. This is what we used to call as. Why it is happening? Because of whom? Earth gravitational force. Understanding? So Earth gravitational force. That is what we used to call as gravity. What we used to call, guys? Gravity. Understanding? So if anybody is thrown upwards, how it is thrown? Vertically. What is that? Vertically. Do you understand? This is
Vertically.
called as vertical, and this is called as what? Horizontal. What we used to call? Yeah, horizontal we used to call it as. This is called as horizontal. This is called as vertical. So if anybody is thrown vertically upwards, after reaching certain distance, again it will falling back towards the earth. Because of whom, Danishkar? Because of earth gravitational force. Do you understanding? So in this case, if you can take, due to the gravitational force, all the objects, every object, whatever it is thrown away from the earth, again they will be accelerated towards the whom, guys? They will be accelerated towards the what? They will be accelerated towards,
Yes.
understanding? So they will be accelerated towards to earth. So that is why in the freely falling case, or else the body is thrown upward, then this uniform acceleration towards the earth, so irrespective of mass, that is what we used to call as acceleration due to gravity. So it is not depend, this acceleration towards the earth, it is not depend on mass. It is not depends on, it's not what? It is not depends on what? Depends on mass. Understanding? So whatever it is, suppose Harish stone 1 kg stone. If Danishkar will stone 500 gram stone, whatever it is, once they will reach the maximum height, then they will be falling towards the earth with the same acceleration. So mass is not at all a matter. So it is independent of mass. What is that, guys? Independent of. That is what we used to call as acceleration due to gravity. What we used to call? Acceleration due to gravity. So which is representing with the what? Which is representing with the what? Small g. Understanding? So that is the force only. Okay. So now if you'll notice it here, Vardhani, I'm seriously saying, if you are not communicating, if you are not responding, at least I need to know either you are understanding or not. Simply sitting, what is the use of this? I don't want like this, such a behavior. So that's all. So now modify the equations, guys, according to the acceleration due to gravity. You modify the equations and tell me what will happen, everybody. All the 4 equations. Please respond, everyone. What is the 4 equations? First equation, tell me. What is the first equation?
V is equal to U plus
U
80.
plus 80. The first equation. Now, freely falling case, R thrown upwards. Tell me, in this case, what is the equation will happen? Velocity will never change. Initial velocity, final velocity. But acceleration, A become what? A become what, guys? A become
G.
G. Understand, everyone? A become G. That's all. So G into T. That's all. That is the first equation. Second equation, Danishkar, tell me. S equals to UT plus half AT square. Now, what is the equation will be modified? Everybody? For acceleration due to gravity. Everyone respond. S is equals to what? S is equals to H. H is equals to UT plus half GT square.
G.
That is third equation. 2as is equals to v square minus u square. So what will happen?
2gs.
2gh is equals to, ready, what happened? 2gh is equals to v square minus u square. Now, last equation, Sn, the distance traveled after the second is equals to initial velocity plus half a into 2n minus 1. So now here what will happen? What will happen here? It will become understanding height traveled by after nth second is equals to initial velocity plus half into acceleration due to gravity divided into 2n minus 1. So these are the equations we'll study when the body is thrown upwards, understanding, or falling downwards towards the earth. And this is for horizontal motion, and these are for what, guys? Vertical motion. Okay, everybody? So this is what? Vertical motion. But in vertical motion, mass is independent or not? Mass is independent of acceleration. Okay, mass is independent of acceleration. Please remember, independent of acceleration. That is what we used to call it as acceleration due to gravity. But in horizontal, mass is matters. Understanding? Mass is dependent. If it is more mass, less acceleration. If it is less mass, more acceleration. Is it okay, everybody? So mass is dependent in horizontal motion. Mass is independent in vertical motion. Is it clear, everybody? Have you understand, Hari?
Yes, sir.
Yeah, please write it. So G is chosen as, and also remember now, as I told you, for example, see, this is the building. This is the house building now. All of you should remember. So when, as we know, for example, as we already studied, if suppose the car speed is increasing, acceleration positive or negative, it is increasing acceleration or decreasing acceleration? Increasing acceleration, which we have been taken positive. Now he apply brakes. Then what we used to call that one? Speed is decreasing. Velocity is decreasing. So then that is called as what? Retardation. Yes or no? So retardation we should represent with what? A is minus. A is minus. Yes or no? So increasing velocity, positive acceleration. Decreasing velocity, what is that, guys? Negative acceleration. Clear? Everyone? Yes, that is retardation, we can say. When suppose Haris is here now Gokul is here. Now Gokul thrown the stone like this. What has been done? Gokul thrown the stone towards the downward direction. So what is the direction of gravity, guys? Pulling force is towards the which direction? Gravity is also towards the same downward direction only. Stone is also falling downwards. Yes or no? Yes. So that the gravity by the time we have to take what? We have to take positive. When the body is falling towards the earth, G has been taken positive. What have to be taken, guys? Positive. Clear? Now, if Haris is thrown stone upwards, now you tell me, Haris is thrown the stone upwards. Now, the gravity is acting downwards, but the stone is moving upwards. So that G will be taken what? G will be taken what? Please respond. If it is thrown upwards, understanding, thrown upwards, then G will become what, guys? G will become negative. Is it okay, everybody? Yes, please. Now, if the throne is falling, understanding, it is falling towards to the ground, then what will happen? If the body is moving towards the earth, falling towards to the earth, what was to call, guys? Towards to the earth, then G is what? G is what?
Positive.
Clear? Now, sir, why, sir? Let us discuss. Now, let us discuss in detail. Now, you tell me, guys. Let me imagine, for example, Arun Kailash is moving in a car. So, he is starting from rest. He is starting from rest in the sense of what is the initial velocity? What is the initial velocity? He's keep on driving. Velocities keep on increases. So he is applying the force in which direction? Everybody, force is also in this direction, and motion also in which direction? Motion also in the same direction. Yes or no, guys? Yes. Yes, please respond. When he is pressing the accelerator, press the accelerator. press the accelerator. So force is also applying the same direction and the motion is also in same direction. So in this case, we can say it is called as acceleration or deacceleration. Arun Kailas, Gokul, it is called as acceleration, which we used to consider as positive. What we used to consider? Positive. Do you understand? Now, Arun Kailas wants to come to rest. He wants to stop his car. Then what is the final velocity? What is the final velocity? Final velocity means he wants to come to rest. Final velocity is 0. So if he wants to come to rest, now you tell me, brakes is applying. So brakes applying means force is acting the same direction of motion or opposite direction? Yes, please. Brakes
Opposite
the
direction.
opposite direction. But still, is it car is moving opposite direction? When he press the brakes, car is moving opposite direction or still it is moving forward?
Still moving forward, sir.
Move forward, then only it will come to rest. After traveling certain distance, only it will come to rest. So you can see here, force is acting this direction and still the body is moving forward. So that final velocity will become 0. So this is only we used to call it as, this is also we can call it as acceleration, but it is decreasing. So that is why we used to consider as what, guys? Negative acceleration. Understanding? Negative or deacceleration, or we can say retardation. This is what we people know. Yes or no? Yes. Now, same way you tell me, if the body started like this, if the suppose this is what the house of your house, imagine now you are standing on the terrace. Now you are standing on the terrace. Now the body is, you suppose you thrown the ball here, you thrown the ball. Now ball is falling towards to the earth. Now you can see. I am throwing the ball downward. So what is my initial velocity? Anybody can tell me? What is my initial velocity? Like a first case, guys. Like a first case motion. Understand what is my initial velocity? If the ball is thrown falling freely towards the ground, initial velocity is 0. Now force is acting. So force is acting towards the downward and gravity is also acting which direction? The force is acting downward. This force only what we used to call acceleration due to gravity. Now motion also same direction. So now this is what in this case G is positive or negative? G is positive or negative? Positive. Understanding? When the ball is thrown, when the freely falling, any body is falling towards to the ground, then initial velocity is 0. And you can see before touching the ground, final velocity will be there. Do you understand, everybody? Before touching the ground. So once after touching the ground, what will happen, Harish? Before touching the ground, it will be having maximum velocity. That is what? Final velocity. So after touching the ground, body will come to rest. So final velocity also will become 0. So that is why always we will calculate before touching the ground. Now, same thing as I said. Now you can see if the boy is standing here and he thrown the ball upward. Now what is the direction of motion? Motion is this direction, but still gravitational pull, the force is acting downward direction. Do you understand, everybody? The force is acting downward direction. So this is what acceleration, we can say acceleration due to gravity. See, motion is upward, but force is downward. So it is G value what it is, guys?
Negative.
G value is negative. Now you tell me, is it possible to throw the body without any velocity? Is it possible to throw the body without force? See, suppose you want to drop the body from your terrace, no force is required. Is it yes or no, Danishkar? If you want to throw the stone from your terrace, is it force is needed? No force is needed. Yes or no? Simply you can drop, it will fall down. So that is why in this case initial velocity is 0. But if the body is thrown upwards, then we need some force or some velocity. That is why here initial velocity will be what? Maximum. Initial velocity is what? Maximum. And final velocity will become what, Hari? After reaching certain height. After reaching certain height, velocity becomes 0. Understanding? So again it will start reversing. So that is what you have to remember. So now have you understand when is G is positive, when is G is negative? Clear, everybody? Please note it down, all the things. So when is that everything, please kindly remember, all of you. So purely a matter of choice and convenience, convention that we should choose a particular direction as positive and another direction, opposite direction, what will become negative. It is always vice versa. So that is what you always need to remember it. Okay. So now that if you'll understand this, then we can say equations of motion of a body dropped from a certain height. So usually we have to study while we are substituting class 9th level, they won't say particular equations again for freely falling and as well as thrown upward. They will say the common equations. What is the common equations? V equals to U plus GT, H is equals to UT plus half GT square, 2GH is equals to V square minus U square, and same way, Hn is equals to U plus half G into 2n minus 1. So, by using these equations only, we are going to calculate all the required things in the thrown upwards or freely falling. But for us, as we all must be enough smart, so we'll even modify and we'll simplify the equations also further for both the cases. One is falling towards to the ground, another one is thrown away from the ground. If you are clear till here, then I'll proceed. Are you clear, everyone? Gokul, Reddy, Harish?
Yes, sir.
Any doubt, anybody, you can ask me. So till here, everybody clearly make it fast. Now, what is acceleration? What is deceleration? Are you understand? When the force and motion are same direction, then acceleration positive. When the force and direction is opposite direction, motion is opposite direction, then acceleration is negative. That is what deceleration we can say, or negative acceleration. Vartini, have you understand or not? Arun Kailash?
Yes, sir.
Now, you can keep heading. What we have to do means, now you can keep heading equations of motion for a equations of motion of a body, equations of motion motion of a body, what will study? Body dropped from a certain height. Body dropped from a certain height. Is it okay, guys? Yes, this is only what was to call. What is another name? I said, what is another name? Freely falling body. What was to call?
Freely falling body.
Freely falling body. Okay. Now, look into the picture clearly. Now, if the freely falling body means body is coming from the top to bottom or bottom to top, it is thrown upwards or coming downwards.
Downward, sir.
Up to down, sir.
Understanding, everyone? So that is what you have to remember. So what is this? You can understand now. What is this, guys? It is the wall. Understanding? So now you are living on the top of your roof or somewhere you are staying. Now you can see this is what we can say wall. Now you can notice it, all of you. A ball is kept here, or the person is standing here. Now ball is thrown downward direction. So this is what freely falling we can say. So because of even no air resistance, we have to consider. Okay, no air resistance, air also not having, then that is called as freely falling. Now freely falling means motion also same direction, and direction of gravity also what, guys? Pulling force. The gravitational force also same direction. So G is positive or negative? G is positive or negative?
Positive.
Positive. Now, if it is freely falling, as I told you, freely falling, initial velocity is what? Freely falling, initial velocity is what, guys? Initial velocity is 0 meter per second. Now, before touching the ground, what is the final velocity? Before touching the ground, what is the final velocity? Final velocity will be maximum. Final velocity will be maximum. Understanding? So after touching the ground, what will happen? After touching the ground, everything will become zero. Body will come to rest. So once body will touch, after touching, then what will happen? Final velocity also become what? after touching the ground, understanding, final velocity also will become 0. But that is why always will calculate when hurry. Always will calculate the final velocity before touching the ground. Okay. So this is not existed for us. After touching the ground, we know we don't want. At what speed or what velocity the body is going to touch the ground, that is what we are going to calculate before touching the ground. So now shall we write the equations, everybody? Shall we write the equations? Now look into the board and tell me. So what is the first three equations? Tell me now. First equation, what is the freely falling case first equation? V equals to what? Speak, guys. V equals to U plus GT. Yes or no? Now as we know, initial velocity is 0. Now freely falling case, what is the first equation? V is equals to GT. That's all. Clear, Hari? Danishkar? Everyone? So initial velocity is what? 0. It is freely falling current. So initial velocity is what, guys? Initial velocity is 0. Always remember, if it is freely falling, initial velocity is 0. Now second equation, tell me. You should communicate, guys. I should not. So H is equal
H is equal
to
to
UT plus
UT plus
half
1 by 2
Now you can
square.
CT square.
square. If initial anything into 0, what was to call? Anything into 0?
0.
Only. So H is equals to what will happen? Ready?
1
GT
by 2 GT square.
half GT square. That is the second equation. So this is the equations for what? Freely falling case. Now third equation, tell me. Third equation, 2GH is equals to V
T
square.
square minus
So if U is 0, U square also will become what? U square
0.
also will become what? 0. So V square is equals to 2GH. Understand, everybody?
Yes, sir.
Yes, that is what we have to remember. So, or else we can write this one. If square will come this side, what will happen? Mathematics. It will become root. Understand? So both are similar. Now, what is the last formula? What is the last formula? Everyone.
Hn is equal to U plus half
Hn
G.
is equals to, you can take, what will come, guys?
U plus
Yeah, Hn is equals to U plus half into G into
half
T
U.
minus 1. Now,
2
as
minus
we know, initial velocity is 0. Then what will happen?
1 by 2
Is
G
equals to 1 by 2 G 2n minus 1.
into 2n
Or
minus 1.
simplified way we can say G into n minus 1 by 2. Is it yes or no? G
Yes, sir.
into n minus 1 by 2. Right or wrong?
right.
Yes. So
Yes,
these
sir.
are the 4 equations of motion. Which case, guys? Freely falling case. Okay. So direct equations. Is it okay? Ready? Arun Kailash, Gokul, no response at all. Gokul is very bad. I never like this behavior. I want always communication. Good communication always leads to improvement. Unless you are not communicating with me, then how I can know you are either understanding or not? Simply sitting and joining in meeting and I think sleeping. Gokul and Vartani, both. So this is the 4 equations. For which case are ready? For equations of motion of a body dropped from a certain height.
Freely falling body.
Freely falling body. What we can say? Freely falling body. Okay. All of you write it. That is what freely falling body. Okay. Now, clearly you have to draw the picture. Now, one clear picture I will help you to draw in this diagram so that you can draw. So, suppose for example, this is the total height. What is this called as, guys? What is this called as? Height. Okay. This is the height. Now, here you can imagine this is what we used to call as ground. What is this called as? Ground. Okay. Now, what is the direction of acceleration due to gravity? This is what? Direction of gravity. And what is the initial velocity? Initial velocity is 0. Okay. So this is you have to remember. So G is also traveling same direction. And okay, the body is initial velocity is 0. Kindly all of you remember that. Clear? Yes, ready?
Yes, sir.
Yeah, that is what.
Yes,
So
sir. Clear.
body is traveling like this direction. So finally it will reach the ground. That is what it is. So okay, initial gravity is same direction, body is also same direction. So this is what we can say. So freely falling case. Clear, everybody?
Yes, sir.
All the 4 equations you write. Next, first four equations. Have you understand freely falling case how the equations will be? Now,
Yes, sir.
equations of motion for a body projected vertically upwards. Equations of motion for a body. Next one you can write. Equations of motion. Equations of motion of a body projected vertically upwards. Projected means what? Ready? Danishkar. Projected vertically
Thrown.
upwards means what it is, Danishkar? Thrown upwards. Understanding vertically upwards or thrown upwards, we can say. What do we to say, guys? Thrown vertically. Okay, thrown vertically upwards. Thrown vertically upwards. Now, first of all, draw the picture. What will come picture? What is the map? What is the picture will come? What is thrown from the
down
down?
there will be ball.
Yes. So what will happen? So you have to take first a certain height. Understanding? It will reach to the maximum height, h maximum. So by that time, what is the final velocity? I told. Final velocity is 0. Okay. Now this is the ground. Okay. This is the ground. So that body is thrown from the bottom. So that initial velocity is what? Initial velocity is existent.
Maximum.
So maximum. So body is having initial velocity and G is acting which direction? G is acting like this direction.
Towards
Yeah, towards the ground. So always G will act towards the ground. So this is what H, total height. Now it is opposite. Opposite means G is minus or not? G is minus or not?
minus, sir.
So who is 0 now? Final velocity or initial velocity? Final velocity or initial velocity?
Final velocity is
Final velocity is 0. Now shall we start, guys?
Yes, sir.
Sir.
Also see what is the sign convention for G. This is also very important. G is what? G is what?
Minus.
Negative. Okay. So here G is
Negative.
positive. So no need to change the sign. But here G is negative. So both the sign convention we have to change it. So now first equation. Speak. What is the first equation? Freely falling case. Sorry. Thrown vertically upwards. What is the first equation? V is equals to U plus.
G is equal to U plus GT.
As we know, final velocity is what?
0.
Final velocity is 0. And G value what? In place of G, we can
Minus.
fix what? Minus G into T.
Negative.
Now you tell me. Now U
So G is equal to
plus into minus what?
Minus.
Minus GT. Now you tell me. G now minus GT will come this side. What will become? Everybody?
plus GT.
Plus GT. So this is the first equation.
GT.
U is equals to GT. Okay, guys? Yes,
Yes,
please.
sir.
Everyone? Yes or no? Yes, that is
sir.
what. So all of you should remember. So, but final velocity will become what? Vertically upwards, initial velocity maximum, final velocity is 0. So that is what final velocity directly we can represent 0. Next, second equation. Second equation, no change, but we can see second equation how it will change. What is second equation? Tell me. H is equal
H is equal to
UT plus half GT square.
half GT
Now,
square.
no final velocity, but still one sign convention should change. What is that? G place will become what? Minus GT
Minus
square.
G.
Okay. Now,
Minus.
equals to what will become? UT plus into minus. Minus half GT square. Okay, everybody? Yes?
Yes, sir.
Yes. That is. Next, third one. Third one, you can see. What is the third equation? Everybody, this is the second equation. What is the third equation?
2GH is equal to V square minus U
Equals
square.
to 2GH. Now you tell me, what will happen? Final velocity is
In place
0.
of G.
So that what will happen? 2GH is equals to minus U square. So now U square is equals to minus 2GH. Is